So I'll try and be brief. This is an introduction to Kubeflow. Again, this is to be very, very crystal clear. This is the OpenShift SIG. Is not my intent to drive this, but with Red Hat, we've collaborated to help make Kubeflow work excellently on OpenShift, and obviously that's a work in progress, but it is absolutely part of our core goals that we make this happen. And this is just a brief introduction to what we're doing in the Kubeflow project. So high level, we come at everyone's heard about ML. It's very, very attractive because it really helps you solve a lot of problems where it's very hard to describe what the answer is. In this case, it's this interesting example at Google. We actually use TensorFlow and some of the DeepMind work to actually make massive improvements and cost savings. This is how you measure data center efficiency, called PUE, power usage effectiveness. Lower numbers are better because it means you are using more of the power, or you have greater effectiveness of the power you're using. At Google, we used TensorFlow internally. This is what it looked like before. We turned the ML control on, and we saw a huge reduction in overall costs, and then we turned it off, and it came back. And so, again, we're very, very excited about ML generally, and we want to help bring it to market. The problem is that, for all the magical ML goodness in the world, most people are over here, and in between the two, there's a lot of pain. And the pain could be adopting your existing processes. It could be understanding whether or not ML actually has an impact on you, and whether or not your problems are actually solvable via ML. And so what we really want to do is help people bring ML into their business without as much disruption as possible. We want to do that in a cloud native way. And by cloud native, we mean these core components of being cloud native: composable, portable, and scalable. In this case, composability means the following. It's obviously building a model is just the very smallest part of solving your problem with ML. In fact, when you look at it, it ends up being all the things around ML that end up taking up the majority of your work. And these components you want to be able to compose them such that you can use the tools that make sense for you. We are not in the fan of delivering a single stack and only that stack that works. We know that every enterprise and every use case is different. We also want it to be portable. A lot of times you'll hear about folks who want to roll out ML, but they're data scientists, maybe training on Macs, and then they or just experimenting, and then they move to an on-premises cluster, and then they move to a cloud cluster. And oftentimes, as they do those movements, they might use different tools. They might even use different ML stacks. And that's obviously a terrible situation because you get the bug that Joe Beta was just hinting at right there, which is, you introduce change, and change introduces the opportunity for breaking. And so in this case, it's not at all uncommon to see, in this case, 6 different systems that might be solving your problem. And each of those 6 different systems needs setup in all these various places. They need to be supported. They need to be rolled out and maintained. And that can be actually quite complicated, even in one environment, let alone the many environments that folks are building and running in. We can skip by that. And then finally, you want scalability. ML workloads tend to be extremely burstable, as you know. When you're training, you want every possible cycle you can get. And then when you're done, you want to shut everything down. And then beyond that, you want to be able to scale kind of in a linear fashion, so that if you're not training fast enough or you're not able to support it, you want to be able to just directly scale up the machines. When we looked at these problems, we basically said what's pretty good about this, pretty good at solving these is containers and Kubernetes. It already supports high scale. It is also highly portable. It runs in many, many different locations, on-prem, in the cloud, on OpenShift, no matter where it is. It supports those things. It's highly portable, meaning you can take workloads, and as long as they're containerized and described properly, they run everywhere. And it's very scalable. It scales up to thousands of nodes, including things like accelerators. So That's great, except if you want to use ML on Kubernetes, it often requires understanding a lot of things, and that's very painful and certainly not something in a data scientist's core job description. And so that's why we have introduced Kubeflow. The idea with Kubeflow is we want to make it easy for everyone to learn, deploy, and manage portable distributed ML on Kubernetes everywhere. So this is our core vision, and we are a loosely bound community. We're happy to change anything, including the vision, if the community decides. As I mentioned, it is highly composable. It allows you to basically create these components and wire them together using nothing more than YAML. It's very portable. It works everywhere that Kubernetes does and uses only native Kubernetes APIs. We don't make any changes. And then finally, it's quite scalable. So we're just getting started. Right now in the box, we have a Jupyter Hub, we have a TensorFlow training controller, and a TensorFlow serving deployment, and then the wiring to make it work on Kubernetes everywhere. And so in the box is just these components out of the overall pipeline or stack or things that we were talking about. We are actively talking to folks everywhere. We already mentioned, and I want to point out the great data science being done by Pachyderm, and we're working with them as close as we can to try and help integrate. And I should also say that all of these steps are not necessarily required to run in Kubeflow or on Kubernetes. We are perfectly okay, and in fact expect that many of these components will stay outside of our process as best as for the foreseeable future. Kubernetes doesn't care where the resource ultimately lives, or excuse me, Kubeflow. Basically, it's, if it's inside Kubernetes, that's great. You can use native Kubernetes service discovery. If it's outside Kubernetes, that's fine too. Just give us the URL and we're fine. So using Kubeflow, this is what's necessary to set it up. There's some boilerplate stuff here. The stuff at the top basically is just initializing a few variables. This KS stands for KSinet. You do have to install that. It's just a packaging system. Then you install the components that you like. So first you just use this registry that we have hosted here, and you can install packages. In this case, we're installing 3 packages: core, serving, and TF job. And then using the namespace, you deploy these components to your ultimate destination, whatever Kubernetes cluster you're looking at, whether or not that's your on-prem, whether or not that's your in-cloud, whether or not that's your laptop. You apply it, and now Kubeflow is up and running. Let's say you don't like TensorFlow, that's fine. You cross out one and you install, sklearn arbitrarily. Maybe you don't like TF serving, that's fine too. You would swap that out. So again, these are all, this is the vision, certainly, but, and unfortunately, those, it's a little PM magic there. Those packages don't yet exist, but we are working as closely as we can with various folks to get things just like that in the system. So that's it. Yes, that is it for now. Our goal is really to take this in whatever direction the ML community and the OpenShift community would like us to take it in. Our goal is really to solve the boring, gross, annoying ML problems that are out there right now, so that folks can work on the higher level. So what's next? We have been doing a number of community meetings. We would love to have you, if you'd like, in those community meetings for Kubeflow, and bring the OpenShift perspective and what it's like running on OpenShift. But really, we're just nailing down the governance proposals. We've moved it out of the Google GitHub repo. That was a frequent request. It is in the Kubernetes, or excuse me, it's in its own organization and repo right now. It is entirely open source. It is Apache 2 license. Fork it to your heart's content. But we're not done yet, and we're still trying to figure out exactly what organization type it should be, what governance model, what the core contributors should look like, so on. We do have a lot of tech that's coming in, we hope quite soon. I mentioned already other popular toolkits: SparkML, XGBoost, sklearn. We want to do auto scaling serving. We want to do TensorFlow transform, model analysis. And we really want this this third bullet point, which is if you are trying to use it and finding problems in any way, shape, or form, or you're trying to contribute and it doesn't line up, please reach out to me, reach out to the community. We want this to be incredibly open and useful from day one. We the next major milestone we think will be KubeCon EU. That's the beginning of May, and we hope to reach a fairly stable state by that time. We're not using labels like alpha and beta, but I would certainly consider things very early right now. And by May, we hope to be in much more of a production use case. And we've, I personally know of at least 8 sessions that have been submitted relative to Kubeflow at KubeCon, and we'd love to meet up and talk. And then finally, you tell us that whatever direction things are going. We want to do this in a very, very community-driven way. We also want to make sure, I come from the Kubernetes world. We want to make sure we do this in a very not Google way. Nothing made us happier at Google than when more than 50% of the contributions came from not Google. I would love nothing more than to have the same in Kubeflow as soon as humanly possible. And whether or not that's other cloud providers like Azure or AWS or DigitalOcean or you name it, could be ISVs, people building inside Kubeflow, OpenShift, Red Hat, all those various folks. We want that to be the representative of the community, not just a couple Googlers, who talk a lot. That is the Kubeflow story. That's where we are right now, and would love to hear where you'd like us to go and what we can do, and you name it. Any questions?
There's only one, and I think it got answered in the chat, and Carol's got one, so unmute yourself, Carol, and see if you can answer it.
Thank you, David. I have to confess I have not used Kubeflow yet, so I'm trying to grasp where it fits in between Kubernetes and the suite of machine learning tools that are out there. Is it more a package manager, or I'm trying to get what it really is?
Yeah. So it's I would classify it pretty close to a package manager for the short term. It is explicitly our goal not to build anything that is already out there, and we much more want to include the things that are being built and being used in production today. However, what we've seen is that many folks will containerize their very useful packages, but then getting that running in Kubernetes in a distributed way is not the easiest thing in the world. And so as a community, we're coming together to basically say, okay, these are the standards for how you might run your workload in such a way that there's a standard between these various steps, and how you might drop your system in here. So for example, with Jupyter, we want to make sure that Jupyter communicates with whatever ML framework is being used in a standard way. And that's not on Jupyter to do. It's up to us as a community to say, okay, if you're going to respond and be an endpoint for Jupyter, you should make these, this available. Whatever, you should use Kubernetes native service discovery. You should, on and on and on. So right now, certainly, I would say it is pretty close to a package manager. But over time, I do see it getting larger and dealing with a lot of the common problems that folks are having today relative to things like standard endpoints and workflow orchestration. Again, we wouldn't build that. We would, as a community, decide on the right orchestration and make it possible. Does that answer your question?
Yeah, I mean that helps put it in perspective somewhat. I'm going to take another tact and just say, from if I'm a machine learning data scientist, whatever, I might use PyTorch, scikit-learn, TensorFlow, NumPy, SciPy, like pretty much are, a variety of things. And from an end user, and this is not like the streaming data production Spark kind of workflow, but I'm at my desk doing analysis on data. There are things like Paperspace, which you can go and pretty much just click a button, you get the whole GPU with everything already pre-configured, that kind of stuff. Same like DigitalOcean now offers, a machine learning instance. And there's I think, two different groups. There's the machine learning end user data science folks, and then there's the, okay, I have to stand this up in production for, let's say I was Netflix with, movie stuff coming in all the time. I'm just trying to see where Kubeflow fits in all of that.
So explicitly, our goal is to reduce the difference between those two as much as humanly possible. Because I've heard exactly what you said many, many, many times. The problem is that when that data scientist finishes their experimentation, they often have to rewrite, throw out, et cetera, their ML model in order to port it to the production one, right? PyTorch and Caffe are a perfect example. Most folks that do work in PyTorch end up using Caffe as the production ML framework. We're trying to reduce that as much as possible. So the idea would be that data scientist who today, paper source is a great example, right? Like, and they're making incredibly, incredibly easy to install. I would love Kubeflow to get to that level of easy to install. But going beyond that, today, I think the standard experience would be, and let me, I will share this again. So today, a data scientist today might look at something like, they may execute these same number of commands, but instead of using something like Kubeflow, they'll do a bunch of pip installs. They might use some apt-get installs and things like that, just to make sure the right packages are there. And then they have to do their own coordination. Oh, things are talking over localhost. They're on this port. I'm not sure. They have to do a whole bunch of stuff. Our hope is that we get this level of stuff down so simply and so cleanly that a data scientist who, certainly they're not going to spend a lot of time doing this, but they are doing that today. If we can have them spin up a production stack on their local laptop such that it does represent what the standard is for the enterprise or the particular job they're doing with all these various components. So, I said, oh, what do you want to swap out TF job? You don't have to swap it out. You could have 6 different ones. We don't care. TF job and sklearn and PyTorch and so on and so forth. But they're all done in the way that the organization has said, okay, yeah, this is what we want to get to when we get to production. That reduces the overall amount of change and friction and pain that it comes to when it comes to taking that model that they trained and got running locally to production. So that's really our goal. It is not our goal that we're trying to make every data scientist into an IT ops person. Absolutely not. That is exactly why we're using Kubernetes to provide that layer of abstraction from everything under the hood and really get at nothing more complicated than just kind of like pip install foo.